What's up, everyone? In this video, I wanted to go over 15 tips of how to learn more efficiently. So this is going to be straight to the point and super actionable for you to master or learn any skill more efficiently. I read this almost 500-page document on how to learn. It breaks down all of the different tips and tricks of how to learn more efficiently, and it's written by a math professor that has taught math for 20 years. I think this is probably the best resource or document on how to learn that I've ever read. I spent 6 hours reading it and compressed all of the main learnings or the main tips into this document here, which I will be going over in this video. Before we start, I just want to say, if you had to learn one skill first, what would it be? It's probably like how to learn more efficiently. And the reason that I think it's that important is because a lot of the stuff or a lot of the goals that you have, or a lot of the, like, maybe you want to live a certain lifestyle, maybe you want to buy a nice car, nice whatever. It comes down to basically if you're able to have skills that can make you a lot more money, skills that can put you in positions where you have the opportunity to achieve your goals, whether it be like if you're a programmer trying to learn marketing, or if you're marketing trying to learn programming. I think like just learning how to learn is the highest ROI skill ever. So let's get started. I have a document of like 15 tips that I thought were the most valuable from the entire document. The entire document is almost 500,000 words, but yeah, these are some of the most valuable tips that I found. So the first tip is, why even bother learning how to learn? He mentions that as in this math professor, mentions that efficiency is important not only because students make progress faster, but also because they are less likely to quit. So I think this is pretty key because learning is very hard at times. If you don't see growth, you're inclined to give up. Learning to be more efficient with your learning will not only get you to the goal of mastering a skill faster, but also decrease the chance of you quitting. So I think that's just like the first tip, is why learning to be more efficient is key. Tip number 2 is to learn the fundamentals first, then be creative. Learn fundamentals first, then try to be more creative and expand past the general knowledge of a certain topic. This is why first augment your knowledge base with examples and problem solving skill experience in the intended direction as quickly as possible. So this is learning the fundamentals, learning like what is already known in a specific topic. Upon reaching the edge of human knowledge, switch over to creative production. My personal take from that is that there's, in a certain topic, let's say programming, there's already stuff that has already well known, and you can find that knowledge in books, blogs. The first task is to learn all that stuff, then and only then be more creative and expand past what is not known. So maybe there's this sorting algorithm that isn't already documented, and you can only find that sorting algorithm, like this new sorting algorithm, after you've learned all the fundamentals, which is why learning the fundamentals and like really having a good base of understanding is key. Tip number 3 is the long-term focus. Especially when I was like learning new topics, let's say copywriting or learning how to record videos on YouTube, it's very hard to see beyond the trees and to the entire forest. And I think especially when you're learning, the key of learning is represented in this diagram. So basically, I didn't understand it, but when I read this, it like made more sense how our memory and how our long-term memory works. So basically, we have like the outside world plus our sensory memory, which is stuff we see and hear. Then there is the working memory. The context that I like thought of it as is like this short-term memory, like RAM in a computer. You can store stuff, but it'll eventually disappear if you keep adding more stuff. So it's like a little bottle of water where if you add more water, will flow out after a certain point. So that's like the working memory. And then there is the long-term memory, which is eventually knowledge that we accumulated that we can remember like days, months, years into the past, into the future. The goal of learning is to move as much of the working memory knowledge into long-term memory. But yeah, that's the goal, which is you don't want to learn something and then forget it in a week. Take that knowledge and be able to use it years down into the line. So that's like the actual long-term goal. So tip number 4, which is to like, this is more mindset, but like to understand that you have more potential than you could think. The passage from the document is that in practice, however, few people actually reach their full mathematical potential because they get knocked off course early on by factors such as missing foundations, ineffective practice, inability and unwillingness to engage in additional practice, or lack of motivation. So I think it's pretty key to understand what will stop you from learning and then just like doing the reverse of it. These are like the different stuff that he mentions why someone may stop learning something. And I think if we have it in mind, it'll reduce the chance of us quitting or giving up early. We're like a lot more capable than like whether you were like how you were stuck in school or didn't do that well in a topic. Tip number 5 is you might learn slower, but once you learn it, you will have equal problem solving efficiency. What I mean by that is in the document, they have this phrase, which is like, while this may seem disappointing for students who generally need more practice than others, we re-emphasize a study quoted earlier in the chapter which showed that the impact of WMC, which is like the working memory context, which is just basically like how efficient you can work, performance was diminished after the task was learned to a sufficient level on a second challenging solution of the same puzzle. Performance was greatly improved in the same WM, which is working memory, load did not impair problem solving efficiency. So what that means is that for several students that was learning a specific topic, so let's say they were all trying to learn marketing, some students may have taken longer to learn the actual fundamentals or the base level of knowledge. But even though some students may have learned slower or faster, after all the students have learned the same level of base knowledge, then they could solve the problems at the same speed. I think this is pretty inspiring because even though like you might learn a topic slower than someone else in school or outside school, after everyone has the same level of knowledge, then they'll still be able to solve, like everyone will solve the same problem at relatively the same speed. This is pretty encouraging to hear because even if you try to learn a new topic and it doesn't seem natural, you should still stick with it because eventually once you get to the same point as everyone else, then you will solve like all the problems at the same speed. Tip number 6, maintain a growth mindset. This one's probably more obvious. Nobody's current knowledge is fixed. To support every student and minimize their learning, it is necessary to provide some students with more practice than others. Again, this is related to tip 6, which is that even if you need more time or if you might need more resource, if you have this growth mindset, which is you'll eventually get to the point where you want to be, you won't give up. And I think just having that right mindset is key to learning more efficiently, because if you have, let's say you have the opposite mindset, which is, oh, I'm not good at math because I did really poorly in my 3rd grade math class. That is like a negative reinforcement, because if you think that, then you'll give up early. The first step is a growth mindset. I can learn any topic that I want. So yeah, I think this is pretty key. Then there is tip number 7, which is deliberate and active learning. So this one was actually a huge unlock for me, because let me explain what these two are. So basically, a deliberate and active learning, which is explained as repeating, practicing skills that are beyond one's repertoire. However, this tends to be more effortful and less enjoyable, which can mislead non-experts to practice within their level of comfort. The way that I took it at is doing stuff that makes you a little bit makes it a bit harder on your life, but it actually increases the level of your mastery of that knowledge. So let me give an example in programming. Let's say I've been programming for 1 year and I'm pretty confident at writing Python scripts that can automate different stuff in my life. So I can write stuff that reads my email, scrape sites. The first approach, I can just keep writing Python scripts and I can make that a career, being like the Python expert. The second path, which is I can think beyond and visualize what's the next step. So the next step might be, oh, I can create that script into an actual app and try to add user authentication and a payment method so that people can pay me for my script. So it's just adding more and more complexity, or not complexity, it's add more and more different skill set of what you already know, and you practice those specifically so that you can get better in a specific topic. Like in the example of marketing, for example, right? So let's say I'm really good at writing Twitter threads. The next step is, instead of just keep writing Twitter threads for years and years, I can try to take that current skill set, which is like copywriting and going viral, and bring it to a different platform of YouTube, which is like, how do I convert like the written word into videos that might be engaging? So within each subject or each topic, there are like this staircase step of what do I learn first, and then what's the next step. Thinking of how you can first figure out like what those steps are, and then figuring out how you can practice those is key. Tip number 8 is the true limit. So this is the passage from the document, which is the key takeaway from this section is that your mathematical potential has a limit, but is likely higher than you think. If this idea still feels unclear, then it may help to draw an analogy to human lifespan. Math is no different. Even if you devote your life to effective study, there's no guarantee that you will become world-class mathematician, but by putting a serious effort into study, you will learn far more math and open far more careers doors than you will otherwise. So I only took a snippet out from the main document, but basically the takeaway is that even though not all of us will become world-class mathematicians, there is some limit where if we put effort and if we study something as hard as we can, there is higher levels of something that we can learn in any type of subject that we want to learn in, right? I think like the common trap with engineers is that there's a mindset that engineers can't market. This negative mindset prevents engineers from even learning how to market. But if you take the opposite approach, which is if you're an engineer and you understand that learning how to market is not that different from learning how to write code. If you have that mindset, you'll eventually reach some peak or level of marketing good enough to sell your products. The true limit of any topic is 10 times higher than society thinks. Tip number 9 is how to learn with guided support. Learning in a guided and unguided scenario. So the two differences are in a unguided setting, like you don't have a teacher, you don't have a really structure, and in a guided setting, there's like a teacher and there's a little roadmap of like what you should learn and not learn. The main tip from this is that they mentioned that it's a lot more effective if you learn with a guided support. I think the first key, which is just to how do you even find a teacher or mentor to help you learn a topic? And then if you can't find a teacher, is there a program online or a program on YouTube that will give you like all the different foundations that you need to learn to even master something? So this is key. I would probably change in my life going forward, which is like for whatever topic I try to learn, I'm going to try to find a mentor or some course. It seems like having a guide is more effective. Tip number 10, which is what are the activities that we do that are most effective to learning? The document starts off with saying how, unfortunately, many types of training methods are ineffective but require little effort and can seem attractive to even the most well-intentioned hardworking students because they create a illusion of competence. So they have this little table here which goes over like all the stuff that we might do to learn a topic. There's stuff like doing practice, interleave practice, summarization, highlighting, rereading. You can see the lowest ROI thing you can do is reread, highlight, and summarize. So I'm going to do less rereading and summarizing because I was trying to do with learning how to do marketing and learning how to do YouTube. And the highest level of like ROI or learning is to doing practice tests, distributed practice, just doing something over a long period. Instead of doing it all today, you do it over different weeks. So this is something that I'm going to change, which is that doing less passive reading, less summarization, and more active learning, doing the actual thing you want to learn. 10, 11 is the importance of learning the fundamentals. This is the passage which is what's more in a subject as hierarchical as math, where each advanced skill requires many simpler skills to be applied in complex ways. Avoiding testing and repetition can lead to struggle. The student has to be fluent with simpler component skills to perform the complex skill. A student must be fully automatic with simpler components first. So what I took from this is that like an example of programming, right? A lot of people set out to create massive software companies, but like at the base level of even learning how to like even making a software is like understanding how do you write for loops, like how do you even get the app online. So I think the key, instead of trying to solve the bigger task first, which is, oh, I have to get this website selling something first, it's more think of the fundamentals and master those first before trying to take on more complex problems. And then he mentions that if a student does not develop fluency and eventual automatically on each skill, they will be doomed to struggle on the more advanced skills. So this again was a key point to me, which is like the importance of fundamentals, that if you don't really master the fundamentals, then it's more likely to struggle in the future when you're doing much harder things in a specific topic. Again, these two are like tip number 12 and 13 are like on the importance of active learning, which is like doing the actual thing you're trying to learn. If you want to make an app, like you should be spending almost all your time on actually coding and not reading books or watching videos on how to program. 80% of your time should be spent coding. Tip 13, if you're active half of the time, that's not enough. The most elite group was spending like almost 70% of their time on this was for a group of elite ice skaters, top of the top, spending most of the time on ice. We can take that into our own lives. If you're trying to learn marketing, 80% of the time should be actually marketing and not reading books on how to market. And then trying to go fast because it's a bit long. Tip 14, which is deliberate practice is hard but effective. You attempt the task on your own, then get feedback on your attempt. I think the best way to do it is like you have your approach that you did, and then you can have a mentor or someone critique your performance, find gaps in your current task that you should work on. So the feedback is key.